Welcome back to part 2 of this series where we learn how to convert between concentration units. We finished question 1 in the first part, and this part will be dedicated to questions 2 and 3. Let's begin by reading question 2. What is the molarity of a 10.5% by mass glucose solution? The density of the solution is 1.03 grams per milliliter. So we've been given the percent by mass, and according to what I wrote in part 1, percent by mass relates the mass of the solute, which in our case is glucose, compared to the mass of the solution, that includes the glucose and the water, times 100%. So we don't know the mass of glucose, and we don't know the mass of the solution. So what I can do is represent this as a decimal first, as 0.105, and create a fraction out of this. The fraction can be 10.5 over 100. And since we're talking about mass, I can write down grams of glucose and grams of solution. Because we're looking for the molarity, remember molarity is the moles of the solute per volume of the solution. So we can find the moles of the solute by first finding the molar mass of glucose. The molar mass of glucose can be found using the molecular formula where we take 12.01 times 6, that's the molar mass of the carbon times 6 carbon atoms, 1.01 times 12, and 16.00 times 6. If we add these up and multiply, you should end up with approximately 180.15 grams per mole. Using this ratio, I can reciprocate it, where I have 1 mole at the top and 180.15 grams at the bottom, and multiply it to this mass times 10.5 grams of glucose. This will cancel out these units, leaving us only with the moles of glucose. Let's use our calculator. 10.5 divided by 180.15 gives us 0.05828. Now that we've written down this number, all we need left for the molarity is the volume. For that, I'll be using this part of our ratio and multiplying it to the reciprocal of the density. Here's what I mean. So I'll take 100 grams of the solution and multiply it by 1 milliliter over 1.03 grams. Remember, this is the density of the solution, so we can do this. This unit and this unit cancel out. Again, we have 100 divided by 1.03, and we have a volume that's in milliliters of 97.087. However, the molarity needs to be in liters. So we have to convert this milliliter number into liters, and we can do that by dividing it by 1,000. We end up with 0.09708 liters. I'm going to leave that on my calculator for a moment, because what we do next is take this number and divide it by that. So let me rewrite this, 0.05828, and remember, this has to be 3 significant figures because they're percent-wise. Dividing that by the number that we found earlier, so I'll click answer, and we end up with 0.600 moles per liter. 0.600 moles per liter, and by all means you can represent this with the capital letter M instead for molar. Let's move on to question 3. What is the molality of 10.5% of mass glucose solution? This time they're looking for the molality, and the definition for that is shown right here. Moles of solute over the mass of the solvent. We already know the moles of the solute, and we can borrow some information from question 2, it was right here. 0.05828 moles of glucose. The mass of the solvent is what the solute dissolves into. Remember, we can't use 100 grams as we did in question number 2 because this is specifically for the solution. So what I'll do, just to isolate the mass of water, I'll subtract 10.5 from 100, giving me 89.5 grams of water only. Molality needs to be in kilograms, so I'll change this into kilograms by dividing by 1,000. So there are 1,000 grams in 1 kilogram. That means I divide this number by that number, and I end up with 0.0895. That's the mass, which I will divide here. Let's use our calculator. 0.05828 divided by 0.0895, and this reduces down to 0.651, and this small letter m for moles per kilograms. And there you have it. 2 examples on how to convert between concentration units.